Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on the IAL Edexcel Pure Math prediction. This is the beta prediction of P1 of January 2025. If you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload another tutorial, you'll be notified. So I want us to go straight into the tutorial so that we can see which are the questions that you are really expected to have prepared before you sit for your exam 9th on Thursday, January 2025, which is basically a few days from now. So we're going to focus on integration. So the first topic that you need to know is how to integrate expressions like these ones. So remember, when you are integrating an expression like this one, you need to increase the power by 1 and divide that new power there. So the second term will be equivalent to 6x3 plus 1, and everything will divide by 3 plus 1. And this expression that we are having here, minus 3 over x squared, can be written as 3x negative 2, so that we are going to as well increase the power by 1, and then we shall also divide by minus 2 plus 1. So this one is going to reduce, and you need to simplify your answer. Don't forget to include your c whenever you are doing integration. That's an area most of the students forget to include that constant, and that is going to attract a deduction of 1 mark. So make sure you are keen to details when you are preparing for your exams, and ensure you know how to perform integration expressions like this one. The next expression we're going to look at, of course, this one we can be able to simplify it further so that we can be able to go to the next one. We have the figure that shows a sketch of curve C. We have curve C, which is a quadratic, and then we have a straight line that passes through the origin and the point M. Now, that is the equation we have for the quadratic, which is y equals to 4 plus 12x minus 3x squared. Then the next question here, we are supposed to write this expression that we have in the form a plus b into x plus c squared. So we are going to use completing square method, and whenever you are using completing square method, you are going to group these terms, and then we are going to factor out negative 3. So we shall factor out negative 3 in this case, and we shall have our equation being 4 minus 3 into x squared plus 4 minus 4x, because if you multiply negative 3 times negative 4, that becomes positive 12. So that is it. And then according to the process of completing the square, we are going to introduce the block brackets, and we shall take x minus a half of this number 4, and then we shall subtract the square of 2 there, and then we can simplify expression, which is shall become plus 12. Then 4 plus 12 gives us 16. Then we shall have minus 3 into x minus 2 squared. So this is the completed square form of this. Now, once you have completed the square, you need to know where does it help you. Whenever you have completed a square of this form, remember this can give you a turning point. And the turning point in this case is going to become 16 becomes the y coordinate, and the negative 2 there, we take the opposite sign to be the x coordinate of the turning point. So we are going to write the coordinate of M, and M, remember, it was a turning point. So which will mean that our coordinate M, we shall take positive 2 there for x. M becomes 2, 16 like that. Now, the line L1 passes through the origin and M. So meaning we have the two coordinates where line L1 passes. So which will mean that yeah, it passes through this point 2, 16, and also it passes through this point 0, 0. so we can be able to find the gradient of L1, right? So we can be able to find the gradient of L1. Gradient of L1, remember gradient is change in y over change in x. So meaning we are going to subtract that like that, and the gradient becomes 8. Now let's look at what we are told. Line L1 passes through this point OM, and line 2 touches C and is parallel to L1. So what does L1 has in common with L2? They have the same gradient because they are saying that they are parallel. So if lines are parallel, they have the same gradient. So which will mean that we can say this is y equals to mx plus c, but we can now use our c, we say just a constant, which we don't know, right? And also we are told that it touches c. If it touches c, it means it's a tangent to c. Okay, it touches c. So if it's touching c, then we can be able to equate this equation y equals to 8x plus k to the quadratic equation so that we can solve them simultaneously. Once we solve them simultaneously, we are going to work out the discriminant, and the discriminant will be equal to 0. If a line is touching a curve at one specific point, it means the discriminant is equal to 0. So which means we are going to equate the quadratic and the straight line that we have said, which is y equals to 8x plus k, then we are going to form a single quadratic equation that we have at this given point. And since it touches, we can be able to say the discriminant is equal to 0. Discriminant in this case will be 0. And remember, discriminant is b squared minus 4ac. Then we shall say that is equals to 0. And if you're getting value from this particular video, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. This prediction is beta prediction. There was alpha prediction, and you can make the best of preparation of your coming exam if you have watched both of the two videos, so that you know that those topics that were not in the previous, not in this video, they are in the previous video. So there is a link in the description that will take you straight to the alpha prediction of P1. So let us now proceed so that we can be able to work out the discriminant. And working out the discriminant, you can see if we put the like terms together and simplify this, our k is going to translate to 4 over 3 plus 4, which definitely becomes 16 over 3 as our final answer. All right, I believe you have understood. We can now write the equation of L2 because we have already gotten what the value of k is. And then now we can move on to the next topic, which I think that you really need to prepare. You need to know how to work with SADs. You need to know how to work with indices as much as you are preparing for this particular exam. But here I have a question that says simplify 1 over 4 minus 2 root 2 and give your answer in the form a plus b root 2, where a and b are rational numbers. So which will mean that you need to rationalize the denominator. And to rationalize the denominator, remember we multiply by the conjugate. A conjugate, you only change the sign of the denominator. Remember we were having 4 minus 2 root 2. Then now our conjugate will be 4 plus 2 root 2. Now multiplying everything and ensuring that you are very, very careful and keen the way you are multiplying, then it will mean that our expression is going to be written like this. So we shall write 4 plus 2 root 2. Now denominator, 4 times 4 will give us 16. Then we have 4 times 2 root 2 will give us 8 root 2. Then minus 2 root 2 times 4 will be minus 8 root 2, right? And then minus 2 root 2 times positive 2 root 2, this is going to give us 2 times 2 will give us 4, and root 2 times root 2 will give us 2. Then it will be giving us minus 8 at this point. So the middle terms basically cancels out, and then we are going to have our expression reducing to 16 minus 8, which is 8. And now we can see 4 divided by 8 is 1 over 2, and 2 over 8 is going to be 1 over 4 root 2, like that. So this is the expression that we were supposed to get in this particular part. Now, hence otherwise questions mean whatever you have gotten from the previous section, you are going to use it to work out the next section. So if you look at the expression that was given down here, it means we are going to put the x on one side. We are going to put those terms with x on one side. And when we do that, we are going to factor out, yes, so I'm going to factor out x and then divide both sides by 4 minus 2 root 2. And this is exactly what I'm going to get. And if you can look at the expression that we are having here, is somehow related to what we were having in the previous part if we factor out 20 root 2. Now, we have rationalized the denominator of 1 over 4 minus 2 root 2, and we got our answer in part A to be 1 over 2 plus 1 over 4 root 2. So we are going to replace this part that is in bracket in part B with whatever we got in part A, and this is going to translate to, if we open the bracket, we are going to have our expression reducing to this. Okay, yes, so basically that's what we're going to get. Remember, we were told giving you answer in the form p plus q root 2, and you can see our p is 10 and our q is also 10 there. Okay. Okay, so we need to move to the next part and get to see which other topic that is quite important for you to prepare. Remember, I'm just giving you the most probable topics that you may be able to be tested. So as much as you are preparing, ensure that you understand this concept that I'm talking about here. Take them seriously as if your life depends on it. So we're going to solve simultaneous equations that involve a linear and a quadratic. So we're going to substitute anywhere we have y, we're going to substitute 3x plus 4, and we're going to substitute into this quadratic that is down here, which will mean that we are going to expand them and then put the like terms together, and you realize that we are going to have a quadratic in terms of x. So once you have put the like terms together and simplified everything, you'll have a single quadratic equation, which is 10x squared plus 18x minus 4 equals to 0. So you are going to solve again this quadratic equation that we have. So solving these quadratic equations, we'll get the values of x, which will mean once we get the values of x, we are going to substitute them. We are going to substitute them into y equals to 3x plus 4, so that we can be able to get also the value of y. So solving x here, we are going to get the value of x being -2 or x being equals to 1 over 5. Then once we have the two values of x, we are going to substitute them into y is equals to 3x plus 4, and basically this is going to translate to -2. And the second part, when we're substituting 0.2, we're going to get 4.6. Now we have solved the simultaneous equations because we have pairs of values of x and pairs of values of y. Moving to the next question, here is we are talking about differentiation, and then you need to know how to find a gradient from a function. You need to know how to differentiate, that's what I mean. And then you need to know how to find the equation of the tangent to the curve, and you need to know how to find the equation of the normal to the curve. So we were given the gradient function f prime of x. Already it's differentiated. So for you to find the equation of the normal, first you need to find the gradient of the curve. And to find the gradient of the curve, we were told the function y equals to f of x passes through which point? It passes through the point 4, 1. So the x coordinate there is 4. We are going to substitute it into the gradient function here. So we are going to evaluate f of prime of x at x equals to 4, meaning that we're substituting anywhere we have x, we're going to substitute 4. Then we simplify that, then we are going to get the gradient of the function at that point for 1. So once we have the gradient of the function, we know that we are told to find the equation of the normal. If it was the equation of the tangent, it means we were to use 35/6 as the gradient of the tangent. But now, since we're talking of the gradient of the normal, it means, since we're talking about the equation of the normal, we need to know that a normal and a tangent meet at 90 degrees, so they are perpendicular. That means that we need to use m1 times m2 in order to find the gradient of the normal. So m1 times m2 must give us -1 because they are perpendicular, which will mean that our m2 is going to be -6/35. Now, since we are talking about a normal that is passing through this point 4, 1, we can now use that point and the equation of the form y equals mx plus c, which is the equation of the straight line. Then we are going to substitute to this equation. Where we have y, we write 1. Where we have x, we write 4. And where we have m, it will be -6/35. So which will mean that we are going to find the value of c of this equation. So our c is going to translate to what? Let's multiply there. So our c is going to translate to 59/35. So we can be able to write the equation y. Now at this point we are done. We are going to substitute the gradient. We substitute the value of the y-intercept c, which is 59/35. But since we are asked to give in that form, we are going to multiply all through by 35, so that we have our equation in the form ax plus by plus c is equals to 0. Have you understood? Right. So this is a question that probably must be there in your P1 paper. Let's move on. If it's not there, they will ask about the equation of the tangent. So in either way, a question on this has to be there. So let us talk about finding the function, because we were given the gradient function f prime of x. So to find the function, we're going to integrate this function that we were having there. So the gradient function was this that was written up there. Let me just move so that we can check whether that's the case. Yes, so that is it. So to move to f of x, we are going to integrate f prime. It will be f of x. Then now this will be 4x raised to power a half plus 1. Then that becomes 3/2. Then we divide by 3/2. Remember how you integrate. You have to divide by the new power. And this becomes -2x. And then this is -8x raised to power -1. Divide by -1. Now that answer becomes positive. So we have our function reducing to 8/3 x2 raised to power 3/2 minus 2x, then plus 8/3 raised to power 8/3x plus c. But we need to find the value of c, what c is. We are going to use the 0.41 that was provided. We substitute anywhere we have f of x, we write 1. Anywhere we have x, we write 4, so that we can be able to find what the value of c is. And after getting the value of c, we are going to rewrite the equation with the exact value of c, which is -13. And now we are done. We are home and dry. We can be able to look into another question. Now, I also have another question here which says y equals to 1 over 8x power 3 minus 24 over root x plus 1. We need to find dy dx, giving it in the form, the simplest form. So dy dx meaning we are differentiating. Yes, remember when you differentiate, you bring the power in front of the variable. So it will be 3 will come in front of x, so it will be 3 over 8 x raised to power 2. So we are going to have 3 raised to power 8 x power 2, 3 over 8 x power 2, and 24, you can see we have negative 24 and the power is negative 2, or 1 over 2 rather, negative 1 over 2. So when negative 1 over 2 come in front, it becomes negative 1 over 2 times 24, that becomes positive 12. X raised to power 3 over 2, because we're going to subtract 1, and when you differentiate a constant you get 0. All right, then now we need to simplify whatever we have. Let's look at the second part. The point P 4 negative 3 lies on C. Find the equation of the tangent. The previous question we did equation of the normal. Now this is the equation of a tangent. So we already have dy dx, which we differentiate in the previous section here. So we are going to have it. Then our x, you can see there is 4. So we are going to evaluate dy dx at x equals to 4. Then we are going to substitute anywhere we have x, we shall substitute 4 there. Then our gradient of the curve at that point for x equals to 4 is what? Putting through my calculator, getting 7.5. And then since we are finding the equation of the tangent, it means the tangent and the curve, they have the same gradient. They have the same gradient. So we are going to work it out and find the value of c, and c is going to be negative 33. Putting it back into the equation, our equation now finally becomes 7.5x minus 33 in the form y equals to mx plus c. So make sure you've understood how to work out that such kind of question before you sit for your exams. Given that k is a positive constant such that k is between 0 and 4, sketch on separate axes the graph of y equals to 2x minus k into x plus 4 raised to power 2. Now this is a cubic function, and whenever you have a square on the bracket here, it means at x is equal to negative 4 we have repeated roots at that point, and the graph there is not going to emerge out of the axis. So we need to know the x-intercept, and something we need to remember, at the x-intercept y is always equals to 0. So y is equals to 0 at the x-intercept, so meaning that we can be able to solve for x in both cases, and the first bracket will be 2x minus k equals to 0. Taking k on the other side, we shall have we're taking x on the other side, we shall have k on the other side, we shall have x equals to k over 2, x equals to k over 2, and the second value of x is going to be what? X is negative 4. There we are having repeated roots at that given point, repeated roots. That's why you can see x equals to negative 4, x equals to negative 4, and the other value of x is x equals to k over 2. Then we're going now to sketch. We're going to sketch the graph, and we need also to know the y-intercept of this graph. We know at the y-intercept, x equals to 0. So we substitute x equals to 0 into this equation, which is going to translate to negative 16 k, and that point will be down here. So our graph will look like this. The graph will look like this. The curve will pass that way. Yeah, that's the way the curve is going to look like. Yeah, this is the curve. And then we have also the curve for y equals to k over x squared. This is how the curve is going to look like for Roman 2. You can see now the next question they are asking down here. We are supposed to state the number of roots for the equation that look like this. We are having 2x minus k into kx plus 4 raised to power 2 equals to k over x squared. How many roots do we have here? Remember, these equations that you are having there that have been equated are the equation that we have sketched. So it means that we are going to have only one root. We are going to have only one root. There is only one root because the two graphs are going to intersect only once. And the graph is, if you draw those two graphs on the same part, you see they are going to intersect only at one point. This so meaning that there is only one solution. There is only one root. Now, the equation for into p minus 2x equals to 12 plus 15p over x plus p, where p is a constant, has two distinct tree roots. Show that this is the case. So meaning we are going to multiply x plus p both sides. We form an equation. Then we shall work out the discriminant of the equation that we have. Now remember, when we will have two distinct tree roots, then it means the discriminant is greater than 0. That is exactly what we are going to do. But if we are told the curves have repeated roots, then the discriminant is going to be what? The discriminant is going to be equal to 0. Repeated roots, all for tangents. But if there is no solution, or if lines don't intersect, you are going to say the discriminant is less than 0. So take note of that, please. So we're going to multiply both sides here. Once we have multiplied, we shall put or expand and put the like terms together. And you need to remember that p is a constant. So we are going to have a quadratic putting the like terms together here, we are going to have a quadratic equation of this form. Now our a is 8, our b is 4p, and our c is negative 4p squared minus 15p minus 12, so that we can be able to work out now the discriminant. And remember, discriminant, the discriminant is usually b squared minus 4ac, right? So the discriminant in this case, because we are told distinct roots, it means the discriminant is going to be greater than 0. Yeah. And the discriminant is gotten by this formula. So our b is 4p, so we are going to say 4p squared minus 4 times a, which is 8, times negative into bracket the value of c. Now expanding this, we are going to have 16p squared, and then we are going to put the like terms together so that we have our equation reducing to whatever we have there as 3p squared minus 10p minus 8 is greater than what? Greater than 0. Now the next part, they are telling you, hence use algebra to find the range of values, of possible values of p. Basically, we are trying to solve a quadratic inequality. And whenever you are solving a quadratic inequality, you are going to treat that equality as an equal sign. You solve it first using maybe factorization, or you can use a quadratic formula. You get the exact values of p. Once you have gotten the values of p like this, you are going now to sketch. Don't forget to do that. You sketch the graph this way, then come here, write the values. Here it's 4, and this one is negative 2 over 3. Now since we want our quadratic inequality was greater than 0, so we want the part of the graph above the line, the horizontal line that we did draw. So the values of p that satisfy this inequality will be the values of x on this side the value of P on this side and the value of C on the other side. So we are going to say these are the values. P is going to be less than or equal to negative 2 over 3, or P is going to be greater than 4, greater than 4. Right. If you have not watched also the previous alpha prediction, consider going and check out which topics did I focus on that prediction, so that once you have watched that one and you have watched this one, you'll be very, very well prepared to sit for your P1 exam. So the next area that you need really to focus on and know how to work out is the use of where you work out the radian measure or circular measure. Yeah, finding area of a sector, arc length. Those two formulas are very important. So here we are told the figure shows a sketch of a plan of a platform. The plan view of a platform consists of a sector D or C of a circle center O joined to a sector A or B A of a different circle, also center O. Then we are told that let's check another information provided. We are told that angle AOB is 0.8 radians, the arc length of CD is 9 meters, and DA ratio AO is 3:5. We are supposed to show that AO is 7.03 meters, correct to 3 significant figures. So we need to go straight to the figure and try to identify the information provided. This is 0.8 radians. Yeah, this angle here. And then we are given also the arc length. We are given the arc length, and the ratio of AD and AO is 3:5. And also we are given the arc length of the 9 centimeters for this particular section here. So meaning that arc length and the angle is going to enable us work out this radius for this part, right? So if we use that, we can be able to work out the radius. And arc length, remember, is r theta. This is a very important formula that you have to know. Arc length is r theta, and area of a sector is a half r squared theta. Area of a triangle is a half AB sine theta. So those basic formulas, make sure you remember them, please, as you are going to sit for that exam. So working out using r and 0.8, the angle in radians, we can be able to find the value of r because we were told the arc length was 9. So this is going to be what? This is going to be 11.25. Now, meaning that we also remember we were given the ratio, so we can be able to express the ratio as a fraction, right? And we can be able to say this is going to be 3:5. We can let AO to be x, AO is to be x, so that we can say AD over x equals to 3/5. So it means that our AD is going to be 3/5x. And remember, whatever value we had gotten r was the entire radius. So we are going to say 3/5x plus x is going to give us 11.25. 11.25. Then we can be able to add these two together so that we can be able to find the value of x, and our x is going to translate to 7.03. And this is meters, which is our value of AO. Our value of AO is that. I believe you've understood how to work it out. We can now move to the next area, and the next area is talking about the perimeter of the platform. And remember, perimeter is distance or round. So if we have AO to be 7.03, then this section here, DA, is going to be 4.22 because we were having 11.5. OD was 11.25. So 11.25 minus 7.03 will give us 4.22. So DA is 4.22, CB is 4.22, and we also have DC, which is 9. Then we need also now to work out the arc length of arc length BEA. So using this angle behind here, it will be 2 pi minus 0.8 radians. So we can be able to work out arc length. Remember, arc length is going to be r theta, and the radius of that circle is sector is 7.03. Then working it out, we are going to get our answer equivalent to 38.55. Working the perimeter, we need to add the distance all round. Remember, the shape was like this, so we were to add this section, everything there, and including this one, so that we can be able to get the total perimeter for this case. Then we shall have our final answer translating to 55.99, which is approximately 56.0 meters, correct to 3 significant figures. Finding the total area of the platform, we are going to use the area of a sector, and the area of a sector, remember, is pi r squared theta, and we're going to find the area of the sector here using half times 7.03 times the angle 2 pi minus 0.8, and this answer becomes what? 100 and what? 35 meters square. And working out the area of this section, we're going to use the angle 0.8 and the radius of OD, and this is going also to be what? I have 11.5 square 11.25 squared times 0.8, and this is going to translate to 50.6. Total area becomes 135 plus 50.6, which translates to 185.6 meters square, probably 186 meters square. So we need to transfer this down here so that we can have our answer well written. Now, using algebra, find the real solutions of this. How do you solve a cubic function? So this is what we are going to work out. Remember, to solve a cubic function, you can factor out x, then you remain with a quadratic equation which you can easily solve by factorization or using a quadratic formula. So our x is either going to be equals to 0, or this quadratic equation that we're having here also is going to be equal to 0. Now, factorizing this quadratic equation that we have at this point, we are going to have our answers 2x minus 7 into x plus 5 equals to 0. So that our first value of x is going to be 7 over 2, or x equals to negative 5, isn't it? Yeah, so you need to know how to work out question to do with cubic functions. You need to know that. All right. All right, so those are the values of x. Hence, find the real solutions of this. You can see the equation that we are having here kind of look like whatever that we were having initially there, but our x now is replaced with x minus 5 squared. X minus 5 squared is the value. Rather, our value of x is replaced with y equals to y minus 5 squared rather. So we can say y minus 5 squared is the values of x, is equals to the value of x. So we can equate y minus 5 squared equals to the x value that we got in the previous section, so that we can be able to get the y value. Yeah, so our y value will equal to 5 plus 7 over 2, or y equals to 5 minus 7 over 2. Or we can say also our y minus 5 squared, y minus 5 squared is equals to 0. So also our x is going to be what? Our y is going to be 5. So there's no way we're going to equate y minus 5 squared to negative 5, which was the one of the value of x, because there's no way you can find a square root of a negative number. Okay, so that is basically what we were supposed to stop at in this particular question. Now, moving to the last question, number 11, you need also to know how to answer a question to do with trigonometry. And here we are told the figure shows a sketch of the curve with the equation y equals to fx, where fx is cos 2x, x is greater than or equal to 0, less than or equal to k. So which will mean that we are supposed to use the information provided in order to state the coordinates of Q and the value of K. And you are also told that the point Q and the point R lies on the curve as shown on the figure. So we can see R is there, which is K0, coordinates of Q. So first, something that you need to remember here is that in the previous alpha video, the alpha prediction, I wrote some notes in that video regarding how you find the period of a trigonometric function for cosine, for sine, and for tangent. And I also, as I am showing you here on the screen, I also showed you how you find the asymptotes of a tan functions. So you check in the description, there is a link that is going to take you straight to that particular video so that you can be able to also watch it out. A period of a cosine is usually 360 divided by the coefficient of x. Now the coefficient of x here is 2, so we shall divide by 2. So the period of this function is 180 degrees. So it's going to make a complete cycle, a complete wave at the 180 degrees. So the first one is a quarter. A complete cycle would be at this particular point. So we have 45 here, we shall have 90 here, then we shall have 135 at this point. Yeah, so we have our period as 180. A period is how many degrees does it take for it to make a complete cycle? Okay, so from there you can see from 180 we add 45, we are going to get 200 and what? 25. So it means the value of K is basically 225, and the amplitude for this wave is going to be 1. Yeah, so we have -1 here, we have +1 here. So meaning that the coordinate of Q is going to be 90, the value of x, and -1 because Q is below the x-axis, and the value of K is 225 degrees. Yes, so basically now the next part also, you are told that given there are exactly two solutions of the equation cos 2x equals to p, we are supposed to find the range of possible values of p, and the question was having how many marks? Was having 2 marks here, and we're going to write the range of values of p to be that, and also shall say that is, if you are new to Proflan YouTube channel, consider subscribing so that when I'm going to upload further tutorials, you'll be notified. I'll be walking you through P2, P3, P4, so you have every reason as to why you really need to subscribe, so that later on we are going to be working together. See you in the next tutorial. Leo hoja itakuwa na shughuli.